Hello, linear algebra students. So this video is for chapter 1.3. We're still on vector equation. Looking at if someone tells us that there is a resulting vector b 2, -1, 6, and I have three vectors that I can use it for linear combination, can I, somehow combine them in a certain way to get b? So namely, I would have a vector equation, right? So to solve this, I would have a vector equation that let's say x1 times a1 plus x2 times a2 plus x3 times a3 is equal to b. So just pretend that it's okay. And then see if the solution exists, then I can do a linear combination because this is the definition of linear combination. Just multiply them in with a constant number and then it will equal to b. But earlier we showed that a linear combination a vector equation is actually just a systems of equation. So that means x1 times 1 -2 0 plus x2 times 0 1 2 plus x3 times 5 -6 8 is equal to 2 -1 6. Yes, one equation having three unknown. But actually this is a systems of x1 plus 0x2, I don't have to say, plus 5x3 equal to 2. -2x1 plus 1x2 minus 6x3 is equal to -1. And it's equal to 0x1, I don't have to write. And then 2x2 plus 8x3 equal to 6. So it is actually equivalent. Okay, we use this to be equivalent. And to solve this is equivalent to doing the augmented matrix, right? Augmented matrix of 1, 2, 0, 0, 1, 2, 5, -6, 8, 2, -1, 6. So this is what we learn in 1.3. And if we can do the reduced row echelon form, then we can solve it. So did I have it here? 1, -2, 0, 0, 1, 2, 5, -6, 8, 2, -1, 6, right? 2, -1, 6. So I have it entered at B. I do a reduced row echelon form of B. So become 1, 0, 5, 2, 0, 1, 4, 3. So this is 1, 0, 5, 2, 1, oh God, 0, 1, 4, 3. 0, 1, 4, 3, and the last row is 0, 0, 0. So I don't have any like 0 to a number, so it is a solution exists. So solution exists consistent. And so what is the equation? The equation is so okay, is B a linear combination of A1, A2? Yes, it is a linear combination because solution exists. It's consistent. If there's no solution, then you say no, B is not a combination, but because it's consistent, you can solve it. And actually, there's infinite solution. There's infinite way of getting from ABC, different combination of ABC to get to B. So because there is only two prefix position, right? But we have one that is free. So there's infinite many solution. We don't have to solve it. So you can see how using system of equation reduce row echelon form, just write RREF, you can actually find out if a vector is a linear combination of the other vector. The way you see I solve it, you can see I start with the vector equation, write the vector out, make it into a system, and then make it into a augmented equation. But you can see that I can actually skip this step. Right? If I have a vectors, I can actually go directly to the augmented matrix because the augmented matrix is actually the column vector and the resulting vector, right? 2, 1, 6 is B, is the result at the other end. A1 is actually here, A2, A3. So solving a system of combination question is the same as solving the system of the augmented matrix A1, A2, A, and B. So this is the vector equation and augmented matrix relationship. If I want to solve a vector equation, I would use augmented matrix of just those columns. If there is solution, then that means B can be generated by the linear combination. If there's no solution, that means B cannot be generated by it. Okay. So that is the first concept. The second concept I want to cover is something called span, SPN, which is very important. So if I have a list of vector n vector, span of v1 to vn means all the combination of v1 to vn for all scalars. So if I add v1, v2, vn together using any scalar that I want, I can say 1 of v1 plus 5 of v2 plus 100 of v3, all of them, every single vector that I include, the vector here is called the span of v1 to vn. And because 0 is a scalar, and you can just add 0 times v1, every single vector v1 to vn is in the span, and also 0 must be in the span. Okay, so this is a set of vectors that contain a lot of vectors. So this vector would have v1, v2, 0, and then v1 plus v2, v1 plus 3v2, right? And then v1 plus v2 plus 5v6, all the linear combination of all of them. So this set is called a span. So the span is this, called this. Span of this set is all the sets. Okay. What is the geometric description of span V and span of UV? If it is span V, one vector, that means it's just the length of the vector. It's just everything on that line in the same direction of the vector V. If a span of two vector, that means all the plane, every vector in the plane, linear combination of everything that is formed by the plane, U and V plane. So the next things I want to talk about is some questions. So as actually solving how to combine two vectors to find the resulting vector. So for example, A1, A2, and B is this. What determine if B is in the span of A1, A2 is the same as can B be written as linear combination, right? So whenever people ask, is this vector in the span of a vector? That means it is in the combination of A1 and A2. And by the relationship between this and the augmented matrix, I just need to know 1, -2, 3, 5, -13, 3. I skip the system of the equation, and I just need to know if there is solution here, right? So put this in, 1, 5, -3. 5, -3, 2, -2, -13, 8. I put it in C. 3, 5, is it 3, 5, 1? Oh, it's 3, 3, 1. Yeah, I made a mistake. 3, 3, 1. 3, 3, 1, right? Okay, so and then I do C. So what do I have? I have a row of 0, 0, 1. So that's no solution, right? So this is the same as 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. So I have x1. I need to solve x1, x2, but I have two perfect position, but this one is contradiction. So there is no solution. So B cannot be. So no. Okay. Because it's a contradiction. System has no solution. That means I cannot find x1 and x2 that can combine to form B. The next question is I have I think it should be A1. I have one vector is 1, -2, the other vector is 5, 3. Can it span all of R2? That means if I have anything xy, can I have a linear combination that can span xy? So the way to do it would be 1, -2, 5, 3, xy to see if there's solution, right? Because this is the augmented matrix. But because this is an unknown, so I can just do this first. I cannot use, well, you can do it by hand. I will just do this. And this one is actually what? 1, 5. Did I have it earlier? Okay, new matrix. 1, 5, -2, 3. Okay. So I do a D. It is 1, 0, 0, 1. So this would be, if I do a combination, is 1, 0, 0, 1. And this would be any number, right? Any x, y, multiply, add together, blah, blah, blah. But I have two prefix and there is no 0, 0 star. So two prefix column, no 0 entry, so there is solution. No matter what your xy is. So yes, A1, A2 span all R2. Does that make sense? So long as I know there's solution that would work. Okay. The last one, this one I cannot do. Reduce row, so I cannot do using reduce row echelon form. So I have two vector and a B. I want to find H is here so that B is spanned by UV. So I want B can be spanned by them. So remember, if you want it to be a combination of another vector, it's the same as doing the augmented matrix because we want to skip the systems equation for 1H. Now, because I don't have like last time where it is XY, this is some number. So I wanted to avoid 0, 0 star. So I actually have to do it by hand. Okay. So to do by hand, I would first of all get rid of the 0 here, and then I would get rid of another 0, and I'll get rid another 0 here. So first, do R1, no, do R1, yeah, -4 R1 plus R2, put into R2. So be -4, 8, -4 times that is -16, plus 4, -3, 1. Put into R2, so be 1, -2, 4, 0, 5, -15, right? And then -2, 7H. So to get rid of this 0, I would do 2 times R1 plus R3, put to R3. 2, -4, 8, -2, 7H. So it become 1, -2, 4, 0, 5, -15, and then 0, 3, x plus h. Now I need to get rid of the 3, but I can divide R2 divided by 5. So 1, -2, 4, 0, 1, -3, 0, 3, x plus h. How do I get rid of the R3? So I would say, do I have enough space? Oh, no space. Negative 3 R2 plus R3. Put into R3. So, sorry, not enough space. So that would become 1, -2, 4, 0, 1, -3. How do I do it? So it would be -3, 9, and then 3x plus h, right?